ఒక్క జేటు చేసుకుంటే సార్ మనము విల్ క్రాస్ మోర్ దాన్ 150 కాలేజీనే కదా నీట్ గా. ఇప్పుడు ఉన్న వాళ్ళు అందరూ జేఎన్టీ సార్, రమాబడం జేఎన్టీ, మీరు జేఎన్టీ, నేను జేఎన్టీ. ఉత్తబాబు సార్ మీరు
జేఎన్టీ సార్, నాకు పిహెచ్డి జేఎన్టీ. ప్రభు కుమార్ కింద
జేఎన్టీ, రాజరావు గారు, మండవ గారు, ఐసర్ సార్ కూడా ఒక కోర్స్ చేసేట్టు జేఎన్టీ. డాక్టర్ అశోక్ గారు, డికే అశోక్ సార్, కైండ్లీ అన్మ్యూట్. ఫేస్బుక్ అన్న మీరు జేఎన్టీ ఉస్మానియా అశోకనా?
సార్ ఫేస్ కనబడతలేదు సార్.
కావడుతున్నా. గుడ్ ఈవినింగ్ అశోక్ సార్. उमेश कुमार साहब, एक बार आपका फोटो नजर आइए।
गुड इवनिंग एवरीवन.
చిన్న కామెంట్ చేయొచ్చా విత్ యువర్ పర్మిషన్?
సార్ స్టార్ట్ చేస్తున్నాం.
మన కోడుద్ది చాలా పేర్లు పోయినాయి సార్. లాస్ట్ ఇయర్ ఓటేసిన వాళ్ళు కిషన్ చీఫ్ ఇంజనీర్ పేరు లేదు, ఇమెయిల్ లేదు. జి విజయ ఫ్రమ్ కొత్తగూడెం లాస్ట్ టైం ఓటెడ్, పేరు లేదు, ఇమెయిల్ లేదు. మరి మన ఐఏలు కూడా ఎస్ఐఆర్ సార్ పెడదామా సార్? ఐ రిక్వెస్టెడ్ త్రూ ఆనర్ సెక్రటరీ అండ్ కౌన్సిల్ మెంబర్ ఐసర్ సార్ బ్రాట్ నోటీస్ ఆఫ్ బిఓఎస్ అండ్ నేషనల్ బిఓఎస్.
అడిగాను సార్ నేను అప్పుడు. మాకు ఏంటంటే మన కమిటీ మెంబర్లు ముగ్గురు లేవు. కమిటీ మెంబర్లు అంటే
చేసుకోలేదు సార్. కమిటీ మెంబర్ ముగ్గురు చేసుకోలేదు. బట్ శ్రీ వరుణ్ కుమార్, ఐ టోల్డ్ హిమ్ లాంగ్ బ్యాక్, వరుణ్ తీసుకోవాలంటే తీస్తాను, సూరాజ్ గారు హ్యాస్ గాన్.
సుశీల్ గారిది లేదు, సుశీల్ కుమార్ గారిది కూడా లేవు. ఈమెయిల్స్ రెండు లేవు.
సుశీల్ కుమార్ సార్ వెయ్యిసారి పోయి చెప్పాను నేను. ఫామ్ ఇచ్చి రత్న గారు ఇచ్చి వచ్చాను పక్కన డిపార్ట్మెంట్ కు. ఆయన కావాలని తీసుకోలేదు.
ఏం చేస్తాం మనం, చేసేది
ఏంటంటే సార్ బై రిక్వెస్ట్ మనము
అన్ని మళ్ళీ అప్డేట్ చేద్దాం సార్. మళ్ళీ వచ్చి మనము ఎవరు లేవో ఇచ్చి మళ్ళీ మనం పంపిద్దాం, హెడ్ క్వార్టర్స్ పంపిద్దాం. ఎలక్షన్
కాదు సార్, ఇప్పుడు ఎలక్షన్ వాళ్ళు మనకు ఎలక్షన్ క్యాండిడేట్స్ కు డాష్ ఇవ్వాలి, ఏం ఇన్ఫర్మేషన్ లేదు సార్. వెరీ సాడ్. The BOS should conduct an election with candidates, nothing was there.
Sir, with your kind permission, sir, Narasimhareddy garu, shall we start, sir? Velli maaku Garland waste radakku 5 minutes pattundi, sir. There is some time that
start చేద్దామా? గార్లాండ్ చేసినాక చేద్దామన్నా?
గార్లాండ్ చేసిన తర్వాత స్టార్ట్ చేద్దాం సార్.
ఓకే
1 minute we'll be back, sir. Just 3
please.
Okay.
గణేష్
బాత్రూమ్ మాట్లాడు.
వీడియో చూపిస్తారా? నేను చూపిస్తా.
లేడీస్ కూడా రమ్మని పర్వాలేదు. స్టాఫ్ అందరూ
ఫస్ట్ దాన్ని
రండి.
మేము గంగాధరి మహోత్సవం నుంచి
ఓకే సార్.
ఏదో ఒకటి
రెండింటికి వస్తలే రమణ
ఎలక్ట్రానిక్ ఇంజనీరింగ్ అలాగే
ఎంతమ్మా జయలక్ష్మి
విజయలక్ష్మి
గారు
పిలుస్తారు సార్, పిలుస్తారు.
లేడీ
ఉండాలమ్మా. అక్కడ ఒకరు ఇక్కడ
Sir, good evening, sir, one and all. This is an opportunity that we are conducting the 11th endowment lecture of Engineer RAJU garu. The keynote speaker for today is the JNTUH Hyderabad University College of Engineering, Science and Principal, Dr. G. Venkat Narasimha garu. Will be delivering the lecture of 3 hours. Today, chairman did not so it's an honor that the chairman and president decided over the event. We also have with us Naik garu, past chairman and chairman elect. We also have with us Venkat garu, then Mandwa Rajeshwar Rao garu, Pratap Babu garu, D. Rama garu, our council member in civil, Ramesh Kumar, Vannam Srinivas, and Pratap Babu garu, and P. Srinivas Rao. Okay, P. Srinivas, Dr. P. Srinivas Rao garu. With this, I request our chairperson, Dr. Aishan Raju garu, please proceed out.
Good evening to everybody.
Good evening, sir.
Respected chief guest and today's keynote speaker of the 11th endowment lecture, Dr. G. Venkat Narasimha garu, Principal, JNTUH College of Engineering, Science and Technology, Hyderabad. Dr. K. Sitaram Babu, Honorary Secretary of Telangana State Center. Professor Dr. Ramana Banotu, Chairman elect. Honorary Secretary elect Mari Ramesh, Council members, past chairman, TS Telangana State Committee members, corporate members of IEI, ladies and gentlemen. I feel it honored to preside over this today's important event, that is RL Raju 11th endowment lecture this evening. So you all know, I am very much, while I am inviting, welcoming the keynote speaker, Dr. G. Venkat Narasimha garu. Personally, I am very happy So to preside over this meeting, because R.L. Raju garu is a giant personality and a very eminent engineer of irrigation department in which I worked. And also when I was the chief engineer, the chairman of this combined state AP State Center, he visited along with his daughter to the state center to request for instituting the endowment lecture. That is the year in the 2015. So we are conducting the 11th this endowment lecture. And when I think I present his greatness when I am telling about his profile. And regarding our Telangana State Center, so we are conducting the endowment lectures in the memory of very eminent people and personality who rendered excellent service not only to the department but also to the society. So one such endowment lecture is that is R.L. Raju, late R.L. Raju, sir, endowment 11th endowment lecture. So R.L. Raju, so he had his civil engineering graduation from the then Deemed Engineering College of Madras University. So you all know that now so many colleges, but in India there's only a few number of colleges are there. That is Deemed Engineering College is one. Because no college is available in either in Andhra Pradesh. He has gone to have his education in Gindi. He took his degree in the 1947, and immediately after getting degree, he joined as a faculty in the same college till 1949. So after that, he joined as assistant engineer in the irrigation department, of the erstwhile Madras government. He was in the year 1957, Madras government was promoted as engineer and posted to Nagarjuna Sagar to investigate and execute the right main canal of Nagarjuna Sagar. And he was also worked as a deputy chief engineer of Nagarjuna Sagar. In the year 1964, he was promoted as superengineer and he worked in Godavari Valley Circle and Godavari Barrage and also irrigation circle Vijayawada. After that, he was promoted as chief engineer in the year 1974 and he was posted to the Srisailam hydroelectric project and also he worked in Kodempadu project. Finally, he retired in the year 1978. He took his office on 4th May 2017. Here I want to add a few things about him. He was a very strict officer and he never compromised anything. Even he never had the powers sought by the politicians also. One such incident is when he was the superengineer in Vijayawada. So the then irrigation minister asked him to do certain things which he has refused. And the result is that the minister wants to suspend him from the department. But the chief minister interfered and tell that such a honest officer suspended is a bad report to the government and ultimately he was continued there. Another important thing is he was very time bounded. He used to give his travel itinerary with hours and minutes. In case he reaches the headquarters 10-15 minutes early, he used to wait some time, that 15 minutes, and try to reach the headquarters. That is the strictness and time punctuality, and he was never compromised during his period. So these are the few lines, and we feel privileged and proud that such a eminent engineer who got a highest esteem in the department is endowment lecture is instituted in our institute, and today we are conducting the 11th endowment lecture. The topic is reinforced soil walls. This is presently presented by none other than the principal of the JNTU College of Engineering, Science and Technology, Professor Dr. G. Venkateswara garu. Actually, this is the latest technology. Almost we are seeing that all the viaducts, already the metro lines and everything where that bridges are there, the approaches are being done by these reinforced soil walls. Otherwise, in conventional walls, they occupy a lot of space and land acquisition is a problem. and also the working is also problem. They are the pre-prep technology they are using it. That's very, very important. That's why when we have requested the speaker to deliver this talk, he is readily accepted. We thank the speaker, Dr. Narasimha Reddy Garu, the principal of JNTH. With these few lines, and again thanking you for organizers for giving me an opportunity to preside over the function, I request the Honorary Secretary of Telangana State Center, Dr. Sitaram Babu Garu, to present the biodata CV of the eminent speaker of this evening. Thank you very much.
Thank you very much, Raju Garu. It's my privilege to read the profile of a very tall personality, Dr. G. Venkat Narasimha Reddy Garu. He's basically BTech from RAC Warangal, then MTech from RAC Surathkal. Now it's called the National Institute of Technology, both RACs. PhD from JNTU Hyderabad and postdoc from Florida International University at USA. He is basically a design engineer and got into the teaching field through Vasavi College of Engineering, and then he was assistant professor, professor senior scale, assistant professor selection grade, associate professor, professor. And now he is at JNTU. All these posts is being at JNTU. He had this post at JNTU, and he is basically involved in entrance and very competitive examinations as far as engineering is concerned. He is coordinator for MSET 2012, coordinator for MSET 13, coordinator for MSET 14, coordinator for MSET ESET 2016, coordinator for MSET 2016, coordinator for MSET 2017, co-convener for MSET 2018, and co-convener for TS Genco recruitment, convener TS Genco recruitment, co-convener Telangana Residential Education Institutions recruitment, co-convener Telangana State Panchayat Raj and Rural Employment Department, co-convener KNR University of Health Services, co-convener TMSET 29, co-convener Telangana State Panchayat Raj Rural Employment Department 2021, Deputy Warden, JNTU College of Engineering, Officer in Charge of Examination, JNTU Hyderabad, Additional Controller of Examination, JNTU, Hostel Manager, JNTU College of Engineering, Procurement Coordinator of TechWip, JNTU College of Engineering, Procurement Coordinator of COE at JNTU, Procurement Coordinator for COE 2, JNTU at Hyderabad, Professor IC in charge of library, then Vice Principal, now he is Principal, sir. And there are actually 5. I would like to shorten his profile, sir. It's a very huge profile, sir. So there are 5 sponsored projects. He has 64 publications, sir. And then he has national journals, 3 papers, international conferences, 14 papers, national conferences, 33 papers. Then organization of conferences and seminars, workshop, there are around 14. PhD supervision, there are around 6. MTech, he has guided around 27 theses. Then consultancy, he has been actively involved in JNTU College of Engineering Industrial Consultancy Services for the past 20 years, in addition to routine site of investigating various major structures, slope stability analysis, design of retaining structures and defoundation, which enhance the image of university, have been taken up as a member of Geotechnical Engineering Division of ICS, generating the funds to the tune of about rupees 20 lakhs per year. The satisfied regular clients include several government, AP State Road, AP State Panchayat Raj, Irrigation Department, Institutional Infrastructure, State Housing Corporation, Ramki Environmental Engineers, Airport Authority of India, South Central Railways, Bell, Ramki Infrastructure, Aparna Construction, Singareni Collieries, Municipalities, Kaktiya Thermal Power Projects, NTPC, Greater Hyderabad Municipal Corporation, AP Genco, Power Grid Corporation of India, AP State Public Health, AP State Police Housing Corporation, Bharat Sanchar Nigam Limited, L&T, Manjira Constructions, PS Telugu University, IIT Basra, Krishna University. And he also has 11 memberships in different professional bodies. And he has basically been teaching in 12 important courses as far as PG and UG are concerned. Administrative participation, he is National Executive Member for Indo Geotech Society, New Delhi. Honorary Secretary of Indo Geotech Society. This was in between April 2006 to 2012. Member State Task Force, Atal Mission for Regeneration and Urban Transformation, Telangana Urban Finance and Infrastructure Development Corporation Limited, 2022. Awards and recognitions. He has UGC Scholarship, Outstanding Achiever, Best Paper Award, Best Paper Award. Then it also has development of laboratories, Geo-Environmental Engineering Laboratory in charge from March 2006 to JTU, College of Engineering, Hyderabad. Initiated and procured the following equipment: 15 lakhs for atomic absorption spectrophotometer from TechCube, World Bank funds worth around 15 lakhs. Then TOC analyzer and FTR through UGC SAP research project worth 24 lakhs. And then loading frame and jack model tanks for testing worth 10 lakhs. Data acquisition system with load cells, LBDST, strain gauge, 18 lakhs. Center of Excellence in Decision Management, rupees 5 crores. Between 2014 and 2017, he has 17 professional training courses attended. Then invited guest lecture delivered 20. And then other economic and corporate activities are around 18. Current areas of research: reinforced soil structure, geo-environmental engineering, geotechnical, earthquake engineering. He is also associated or visited foreign universities, Indonesia and USA. Thank you very much, sir. It's such a wonderful and huge profile, sir. I now request the chairperson, ISN Raju garu, to continue the further itinerary of the program.
Sir, thank you, sir. Thank you.
Please continue your presentation.
Thank you, sir. So, good evening to the distinguished engineers and the members of Institute of Engineers, and Dr. K. Sitaram, Secretary, and Ramana Nayak garu, Dr. Ramana Nayak garu, the Chairman-elect, and Satyanarayana Raju garu, the President of this program. And I am honored and privileged to just deliver the lecture, endowment lecture on reinforced soil wall. That's RAJU's 11th endowment lecture. So it's my privilege. So this is my actually area of interest. So just I will briefly introduce what is this one. There is this reinforced soil concept has been introduced by Henry Vidal in 1960, and of course there are so many lakhs of structures were built all over the world, and it has gained more popularity and the fame and other things from the 2000 onwards, right? That is mainly because in 1995 and 97 the scope in Japan, that's earthquake, and another Northridge earthquake in US. So at that time it's a Richter scale almost 8. And so many retaining structures were collapsed or damaged, but reinforced soil structures, even though they were designed for a mere specific seismic quotient, horizontal seismic quotient of 0.3, and many of these structures were not even designed for even specific loads. They were intact except peeling of panels and minor changes. And another beauty of the reinforced structure is, if there is slight damage, only we can repair that one. Whereas if you go for a conventional gravity retaining wall or cantilever, if it fails, you have to remove and reconstruct it. So thereby it has gained more popularity and the attention of the engineers all over the world, and it has been extensively used throughout the world. That's reinforced soil structures, and most of you are known this Outer Ring Road project also, Hyderabad Outer Ring project. So significantly they use reinforced soil technique. Now, I want to emphasize, right, even though it is a conventional, just I want to see what is the level of the safety, right? So even though we are designed for a specific quotients, but we will get much higher the safety than that, so that we can safely go for it. So just some of the structures, right, the beautiful structures which we can see, right, all over the world. So these are some of the structures, reinforced soil structures, which were existing, and almost we can construct as sir has said. So we can go for the reinforced soil almost vertical, whereas it is not possible in conventional, especially the flyover ramps. That is, all those were approach ways were all are reinforced soil walls only. So these are some of the beautiful structures. Just before going to the actual topic, I would like to show this the photographs, so that we will have a glimpse of the reinforced structures. They are extensively used. And Just coming to the design, generally we will go for external stability and internal stability. Just external stability is almost similar to the design which we will use for conventional reinforced, conventional retaining structures, like so factor of safety against overturning, sliding, and bearing capacity failure, and deep-seated failure. Now, in addition to this external stability, in reinforced soil walls, we will go for internal stability, that is tensile failure and pull-out failure. These are the two failures generally, we have to be safe. So I am emphasizing on this with a different approach. Maybe generally, if you see in almost all the textbooks, there's a conventional way of the designing this is in a different way. Now I will go in a slightly different way. And two of my students did even PhD on the reinforced soil walls and reinforced slopes also. So they have used that horizontal slice method. So we'll see. Right here, if you see the axial pull-out mechanism, we will assume that while designing, the reinforce comes out axially, and based on that, there will be bond resistance will develop above and below the reinforcement. These reinforcement may be strips, geogrids, or geotextiles. Of course, better one is the geogrids, where you will get a passive resistance also. In case of geogrids, so the shear failure will be slightly above the geogrid, so you will get more resistance. The interface friction will be more, almost we will take phi r equal to phi, that is interface friction is equal to angle of shear resistance. Whereas in geotextile and other things, will maximum will take 2/3 or 3/4 of phi. So, and in addition, you will get a passive resistance in the case of geogrids. That's why always it is advantage. So here in 1992, Joel has presented additional passive resistance will be there in the geogrids. So thereby, in addition to bond resistance, this bearing resistance also will be there, which will significantly improve the factor of safety. So generally, which in many cases will not be considered. Now, just I want to give a glimpse of the factor of safety. Just now at the beginning of this lecture I presented, that is Kobe earthquake in Japan and Northridge earthquake in US. So their magnitudes are almost in Richter scale near to 8, and in one case it is more than 8 also. That is, it's a major devastation. Even then, the reinforced structures which were not even designed for seismic force are also intact with minor peeling of facing panels, something like that. So then it attracted us. Then we focused doing research on these aspects. Then we studied, so why so much of factor of safety is there. So then we got that is when we analyzed. So let us say if the failure plane is something like this. So here this slide, it will slides downwards. So here this reinforcement will be pulling downwards, not pulling horizontal. So thereby you will get an oblique resistance. Let's say if you take a paper on and you keep it on a table, and if you keep some weight over it, let's say if you pull horizontally, so you can apply less pressure. But if you want to pull downwards, so you need to apply more force. So that is the oblique effect, which generally no one will take. So that's why when we consider this, so there is a significant improvement. So here is example which shows in the C. So this is an axial pullout, whereas in the case of B, it is something like this. So here oblique pullout will be there. That is the main contributing factor. And these are different methods, right? So I don't want to emphasize more on theoretical part, right? Because almost all of you are the practically doing engineers. So just I'll show the glimpse, and I will focus on the how much improvement in a factor of safety will be there. And these are the methods which we can use for design of reinforced soil walls. And so here, this is the effect of oblique pull, a bit clear picture. Let's say these are the geosynthetic layers. So here, this reinforcement, it's pulling downwards because the soil is failing. It slides down and it introduces this oblique force here. There's a vertical force will be acting on this that will resist much more. So that's the main idea. And in addition, another factor of safety which we found is, let's say if you use geosynthetics, we are using nowadays geosynthetics as reinforcement, mostly geogrids. And they have the elongation property. And because of that also, it is giving additional factor of safety. So these are the two main reasons which are contributing for the factor of safety much higher than what generally we are assuming. That's the main idea. Now for this, what typically we use a different, that is generally we use vertical slice method in geotechnical engineering. Here we used a horizontal slices method because so this is a top slice, and in between this thick the solid line indicates the reinforcement, and this dashed line, that is one slice. This is one slice, horizontal slices. So we divided this into a number of horizontal slices, and reinforcement is in the middle of the each slice. So then it is analyzed, right? Something like, so this is one slice. So here, this is the reinforcement. It is subjected to pull, horizontal pull, something like that, and normal force, shear force, all the forces which are acting on this, and it has resolved, right, by taking algebraic sum of vertical forces equal to 0, and the algebraic sum of moments is equal to 0. And for the whole wedge, so this is the resistance which we are getting from the slice. That is what is found. So slightly different than vertical slice method. And so this is the bond resistance which we are getting. And this this equation indicates the tension which is mobilized in the reinforcement. And this is the maximum bond resistance which we are getting. So using this, we are finding a factor. This is the maximum bond resistance. That is, if there are so many m layers, so we'll sum up all the layers bond resistance divided by the mobilized tension. So you will get the factor of safety. It is easy to calculate. And further, generally we used a factor of safety. That is, this is mu indicates relative stiffness, and WL indicates, let's say if a wedge is sliding, so it's about to fail. So the WL, we are taking it as 0.001 WL by L, in other words. So that is 0.001 L to this one. So, and phi R, and N is number of layers from 1 to 5, and from length of reinforcement, that is generally we'll go for 0.7 H, but we tried from 0.3 to 0.8 H, right? So that how it will varies. So this is the beauty of that is the effect of oblique pull. Let's say if you take a reinforcement that is the factor of safety, if it is a conventional factor of safety, all these lines would have been horizontal lines. So it is inclined, right? So if phi, that is the angle of shear resistance of the backfill soil, if it is phi, so 45 degrees, so how it looks, right? So if you see, with the increase in the angle of shear resistance of the backfill soil, bond resistance increases significantly. Let's say if you take phi is 20 degrees, almost it is looking like horizontal, which is conventional factor of safety. That is generally we use term factor of safety C, that is conventional. Whereas here you can see there is a significant, here it will be around 12, and here it may be around 15, almost 25% improvement, only when you consider as bond resistance. Still we have not considered oblique effect. So this is how much there is a variation. And even if you compare the improvement in factor of safety, right, you can see if 20 degrees you are getting somewhere here, and if it is 45 degrees, you are getting a factor of safety of more than 10, right? So even with a small deformation in the sliding wedge, this is the smallest, that is 0.001 times L, it is WL by L. So that's how we are getting. So you can see, generally we will use a factor of safety of 1.5, but here you are getting almost all the factor of safeties are much more than the required factors of safeties. And all other factors I assumed constant, that is number of layers as 5, and L by H as just 0.5. Generally we will go for 0.7, but I have taken, so how it is affecting and so on. And similarly, this is the factor of safety, FST, that is considering only bond resistance, and this is angle of shear resistance. And for different L by H values, you can see the how factor of safety is increasing, right? You can see here. So this is almost around even 0.3, around 40 degrees, it will be around 3 factor of safety. And if you take L by H 0.7, generally widely we'll go for 0.7. Even if factor of safety of 30 also, you can see the factor of safety you are getting is almost like a 5, which is much higher than the 1.5. Generally we'll design for a geosynthetic reinforced soils. Generally for steel strip, we'll go take a factor of safety of 3. Otherwise, for geogrids, we'll take 1.5. But we are getting much higher only from the bond resistance point of view. And this is another case. Let us say if there is a little bit cohesion also, how it affects. Generally, we will avoid the cohesive soils because drainage is a major constraint. And if more cohesion soil is there, if there is, it swells, it will induce a lateral pressure on the retaining wall and it will damage the retaining wall. That's why we'll try to avoid backfill soil. Even in conventional retaining walls also, we'll try to go for the cohesionless soils. But nowadays it's very costly. Sand has become very expensive. If there is a little bit of cohesion, like red soils, which comes under SM soils or SC category soils, so still you can make use of that. That's why we have emphasized on even a little bit cohesion also we have taken, and still it is working well. And even we tried with the factor of safety, that is seismic coefficient from 0 to 0.8. 0 indicates so no seismic force, we don't consider this is static case. And in other case, that means if seismic activity is there, right? So generally around 0.5 specific coefficient or 0.4 means it is equal to the Richter scale magnitude of 6.5, something like that. So you can imagine so how much there will be reduction. So even then, after reducing, even if you consider specific force also, you are getting a significant, much higher than what is required. That is another case. And coming to this, the next case is the analysis of inextensible sheet reinforcement subjected to a transverse force and also displacement. Here, we analyzed slightly different. That is, one is linear subgrade response and non-linear subgrade response. That is stress displacement ratio, linear we assumed, and next is non-linear. These are the two cases we assumed. For that, let us say if a reinforcement layer is something like that, AB, and it's subjected to a downward pull P, and WL is the deformation, right? When just you apply the load, how much it deforms. So this is the definition scale based on this. So when the deformation is there, it bends something like this. Originally, it was a solid line. It will become a dashed line, right? Of course, this image is exaggerated one, but so how this is? So here, the stress displacement response of backfill soil, that is, we consider it as a Winkler spring, something like that. So stress displacement is a linear. So this is the initial assumption. And so we calculated forces, and of course, so the equations we developed. So I'm skipping this because it looks boring, but the end results, right? Finally, so the 3 factors of safety. So one is a conventional factor of safety, assuming only axial pullout. And just now, whatever the figures which we discussed, that is FST, which is modified factor of safety, with increase, considering only increase in tension or increase in bond resistance. Whereas FSPT is another factor of safety, where we are considering the upward force, because you are pulling the reinforcement downwards, because the wedge, that is failure wedge, is moving downwards in inclined fashion. That is creating an upward force. If you consider that counters the downward force, so thereby there is a significant improvement. So that's why. So here, this is FSTP is third case. So where when we consider the upward force also, just you can see how drastically the factor of safety is increasing, right? So when we consider the displacement from 0.00L to 0.01, so here you can see this is a percentage, right? You can, even if you consider the 30%, that is 30 degrees angle of shear resistance, if you consider that backfill soil angle of shear resistance, you can see how the factor of safety is increasing. So almost, let's say if it is 0.005L, you can see around factor of safety is reaching 12, right? And if you go for 35, so it's much higher. Even at very less high, it is reaching a factor of safety of 21. So much of a factor of safety is there. But we need to remember there are certain failures which we will see in newspapers and other things, where so the major cause of excessive deformation or creep is due to wrong selection of backfill soil. So you can see here for 20 degrees how the factor of safety is varying, and for 30 degrees, how a factor of safety is varying. Just by seeing this, you can imagine there is so much of effect will be there, an angle of shear resistance of the backfill soil. That's why choosing backfill soil is very important. So there are certain mistakes which are doing practically, and few reinforced soil walls were failed in the recent few years. That is mainly because of wrong selection of backfill. So, but it doesn't mean that so we should be careless. But here the factor of safeties you can see on different cases. Here length of reinforcement is generally let's say different case 0.5, 0.7, 0.9. So these thick lines indicates factor of safety FSTP, whereas FST is only factor of safety considering the pull out, right? That is increase in bond resistance due to there also this is also due to oblique, but that oblique effect only in increasing bond resistance we are considering, whereas here additional upward force also we consider. That is the difference. So here these dashed lines, actually these are inclined lines, because when we see the magnitude in this scale, it is looking like horizontal. So if it is horizontal line, that is FSC, that is conventional. These are also linearly inclined lines, but so these are the factors of safety is 0.3, 0.5, 0.7 corresponding to this. The thick lines you can see 0.5, 0.7, 0.9, and how the factors of safeties are varying. So much of factor of safety which is creating in the reinforced soil walls. So this is another case when number of reinforcement layers, right? Here typically I took 3 layers, 5 layers, and 7 layers for FST and FSTP. So this is 3, 5, 7. Right, and other rest of the figures, just rest of the parametric values I kept constant just by varying. So you can see how drastically these are varying. So one of the beauty of reinforced soil walls is if there is more deformation, right? As you see here, so if there is a sliding, that will create more the bond resistance, and that will create more resistance as it tries to slide, it offers more resistance. That's why we can able to construct the reinforced soil walls or reinforced earth walls, which we are seeing up to a greater heights. Now, so earlier the first retaining wall which was constructed very high was Sikkim Airport, where they have constructed more than 60 meters height reinforced soil wall for extension of a runway. And of course, but few years back, about 10 years or something or less than that, so one of the reinforced soil wall it's constructed at Kanakadurga temple in Vijayawada. So you can see, so that was also almost more than 40 meters, right? So that is the beauty which we cannot construct so much height using conventional retaining walls. So if there is any deformation also, there is so much of the increase in the factor of safety. If it deforms also, there is an increase in factor of safety. Right. In addition to the bond resistance, and even here I didn't consider the actually passive resistance which mobilizes in the geogrid. Geogrid, there will be apertures will be there. Inside aperture, there will passive resistance is mobilized. So here, just I considered a geotextile reinforcement only, just for geotextile, and these are the factors. Right. If you see the pull-out force due to the transverse displacement is very, very significant here, right? When you compare with the only axial pullout. In axial pullout also we'll consider bond resistance, but additional bond resistance which we are considering is just, I will go back. Sorry. So here, for this bond resistance, we'll add that is upward normal force into tan phi r. So that is additional bond resistance which we'll get it. Because of that, so you are getting more resistance, right? So that's why so much of factor of safety is improving. And this is the work generally done. This work was done by one of my PhD student, and we got awarded about 5-6 years back. So this is the significant, and the main emphasis why I chosen this is, so nowadays in almost all the departments they are using extensively reinforced soil walls. So just the factor of safety which generally a design engineer will do is only they will consider actual pullout. If you consider oblique pullout, there is much higher factor of safety is there. But this I am emphasizing not to be, we can say, take it granted, provided backfill soil is a granular soil. That is, the phi is better than 30 degrees. Always you will get much higher than that. That's why. So if you see, even in the recent cases, maximum if you search in Google also, you will find Kobe earthquake and Northeast earthquake, the case studies. So almost all the retaining structures, that's conventional retaining structures were collapsed, almost 80%, 90%, even though they are designed for seismic. Whereas reinforced soil walls or other reinforced embankments, which were designed, which were not designed for seismic force, or designed meagerly for a horizontal seismic quotient of just 0.3 also, withstood the seismic force of 0.6 or 0.7 horizontal seismic quotients. So that attracted us, and then we focused on this. And similarly, we also focused on even embankments also, but there also we got significant results. So the mere conclusion of this is, with increase in the WL, WL is the downward deformation, and L is the length of reinforcement, or the relative stiffness of the backfill soil, or angle of shear resistance, or number of layers. So all these, whatever we consider, there is a significant increase in factor of safety. And whereas if you go for FSTP, is exponential the factor of safety is increasing. So this is the beauty. That's why, so wherever possible, even cost-wise also, if it is more than 6 meters, 7 meters height reinforced retaining wall, naturally it is economical than conventional retaining walls. As the height goes on increases, and the economy will be, it is much cheaper when compared with the conventional. Of course, conventional maximum you can go for 10 to 12 meters of that is counterfort or buttress reinforced buttress retaining walls, and beyond that generally it is very expensive and it's not advisable. But here there are, you see numerous structures which are much more than 20 meters, 30 meters. Already saying there are so many structures which were all over is there. They are standing testimony, and even the, I think, Kanakadurga temple, they have used that parking lot by constructing the reinforced soil wall. That's more than 43 meters or something like that. So these are some of the points just I thought I would like to share with the engineers who are working in the different fields, which they can take it with confidence. So any doubts regarding this, any questions, I'll be happy to answer, sir.
Okay, thank you very much, sir. Dr. Professor Venkata Narasimha garu. Very important topic now is a requirement of the order of the day. Any engineer, whether he may be irrigation engineer or roads and building department engineer or public health engineer, everybody is going for this reinforced soil walls, because you all just now told that it could be possible only 40 meters height. The flyover in Kanagurga could be possible because of this reinforced soil wall also. That is the only thing. Another important thing is not only structurally economical, but the other aspect of the rainfall, that the land acquisition is a big problem, because in urban areas, so that much area will never happen, and with a conventional retaining wall, we can never have that one, because it could be possible only because of reinforced wall. This is the order of the day. And almost everybody has dispensed with this conventional retaining wall, whether it is a bridge or flyover or a railway bridge or a irrigation dams, and also things are there. And sir, very excellently you have given the genesis of this reinforced wall in 1960 and subsequent developments, and you have displayed so many structures. So with across the world about this beautiful reinforced wall technology and other things. So to my knowledge, sir, actually this reinforced wall technology that started in combined Andhra Pradesh in Hyderabad, the flyovers, especially the Paradise flyover and other flyovers, they were the first built with these reinforced walls only. That is the first time, and everybody has a lot of discussion that how it will, all the things are there, but they proved very successful. And now it is all structures it could be happen because of this one also. Another important thing, sir, we have depth. We have gone into depth of the design aspects of this the reinforced wall. How effective even seismic effect also it can be taken. What is the difference between conventional wall and also the reinforced wall? And reinforced wall are found to be very safe even in zones of these seismic zones are also that is very, very important. Another important thing is even failure of conventional wall, that capital cost again have to reinvest. But whereas in these reinforced soil walls, so it can be rectifiable at a lesser cost, and also the entire length need not be there. Wherever the damage are there, that can be rectified. And ambience also very beautiful. I think in urban areas also, any traveler, people are there, you can have a beautiful ambience of this reinforced wall, unlike a massive conventional wall. Actually, what sir told is that normally these conventional walls will go for up to 10 meters. If it is more than that, it is nothing but a dam. So it is very impossible to construct that one, and that is very, very difficult also, actually. So with these few lines, and sir, we are excellently, the technology is very much required. You have gone into depth of it one. You have beautifully explained about the factor of safety of a conventional wall, and FST and FSTP also, the difference and all those things with the graphs we have shown it, sir. It is very, very useful. Of course, in 45 minutes, people, the engineers may not able to digest the entire depth of it one, but we are quite open that whenever people are there, that can be done. So with these few lines, any of the participants want to have any doubts or anything else, the platform is now open.
Can I speak, ISN Raju, Dr. ISN Raju garu?
Rao garu, retired chief engineer from public health. So most welcome, sir.
థ్యాంక్స్ అండి, నమస్కారం. మళ్ళీ మనం మీట్ అవ్వడం చాలా సంతోషం. అలాగే డాక్టర్ నరసింహారెడ్డి గారు మొన్న రీసెంట్ గా మీట్ అయ్యాం అనమాట వేరే ఇష్యూలో. చాలా రిసెప్టివ్ గా ఉన్నారు. రియల్లీ వీఆర్ వెరీ థ్యాంక్ఫుల్ టు హిమ్. అండ్ దిస్ ప్రజెంట్ లెక్చర్ ఈస్ వెరీ, వెరీ హైలీ ఎన్లైటింగ్ ఫర్ అస్ ఆల్సో. దాని సింప్లిసిటీ అండ్ కాస్ట్ ఎఫిషియన్సీ అండ్ ఆల్సో ఫ్యాక్టర్ ఆఫ్ సేఫ్టీ కూడా చాలా ఎక్కువ ఉంటుంది అనే విషయం అనేది చాలా ఎన్లైటనింగ్. అది మాకు కూడా కొత్తగా తెలుస్తుంది. సో ఇంకోటి ఏంటంటే ల్యాండ్ అక్విజిషన్, మీరు అన్నట్లు ల్యాండ్ అక్విజిషన్ నీడ్స్ కూడా తక్కువ అవుతాయి అనమాట. సో ఓవరాల్ వీ కెన్ గో టు గ్రేటర్ హైట్స్ అనేది కూడా ఒక మంచి ఎన్లైటనింగ్ ఫ్యాక్టర్. సో వీఆర్ వెరీ థ్యాంక్ఫుల్ టు డాక్టర్ నరసింహారెడ్డి గారు ఫర్ ది ఎన్లైటనింగ్ టాక్. థ్యాంక్ యూ వెరీ మచ్.
We can have a full-length session physically mode after some time.
Sure,
Yeah.
sure, sir. So actually, we have so many, but I cut short. So 30 to 40 minutes means I cut short.
Yes, sir. It's the beginning, sir. We can continue this session.
One more, our student is actually chief engineer in South Central. Now he's retired actually. He did an embankment, reinforced embankment, so that they can reduce the bottom width of embankment for railways. So that he also
Sir, it's open. Any of the participants there is open for another 1 or 2 questions. Anything is there? And our chairman elect Raman Naik want to speak, sir.
Good evening, sir.
Sir, good evening. Good evening.
Sir, we are very happy. We got such a eminent professor today. Very good talk, sir. Highly appreciable, as Kondarao sir said, and our Dr. Raju garu. We are very happy, sir. In future also, we are requesting kindly give some time for our R&D and also water management, sir. Thank you, sir. Thank you.
Sure, sir. Definitely, sir. Thank you. Thank you very much for giving me this opportunity to deliver a lecture on behalf of Institute of Engineers.
Okay. Thank you very much, sir. If there are no, I request the Honorable Secretary to perform the vote of thanks.
Sir, thank you very much.
Thank you, sir.
Narasimha garu for having given such a wonderful lecture, sir. Highly need of the time, sir. Reinforced soil walls. I also thank ISN RAJU garu for having chaired today's event in the absence of Venkat Subbai garu. I also thank some of the esteemed guests who are joined later. Kondarao garu. Then we also have Umesh Kumar garu. Then Ashok garu. Sir, with this, sir, I thank Ramana Naik garu for also having part of it, Rama garu for having part of it, and Ramesh garu also part of this event, sir. And with this, I appreciate all to stand for national anthem, sir.
जन गण मन अधिनायक जय हे। भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Good night, all of you, sir. Good night, and all the best for advance happy Diwali.
Thank you.
Good night.
Good night.
Garu, marokasari
Thank
Good
you,
night.
sir.
for Professor Sivling, Dr. Reddy sir.
Thank you, sir.
Kondala sir, namaskaram sir.
నమస్కారం సార్ గుడ్
Dr.
నైట్
P. Srinivasarao garu, namaste.
నమస్కారం గుడ్ నైట్
Sir, బాగున్నా?
బాగుంది
శ్రీనివాసరావు గారు గుడ్ నైట్
గుడ్ నైట్ అండి కొండలరావు
Thank you. चलिए भारत माता को जय जय अब मैं अर्धों में